What if we have no convolutions, no attention, and no problems? My project is called Just Mix It Up, and it utilizes MLP mixers. So the context is that CNNs and vision transformers have historically performed really well, but they take a bunch of TPU time. So MLP mixers are better at this without taking a lot of TPU time. And then my objective with the project was to replicate the results of the MLP mixers and then evaluate it on smaller data sets that they do not post individual results for. I also explored the effect of activation functions in the linear projection layer. So what's an MLP mixer? It's just a bunch of MLP layers stacked together after you get the linear embeddings after the linear projection layer, and then mix it up and transpose it to get n number of times to get the final outputs. That's about all the detail I can go through in the time frame. So this is the JAX code given by the authors. They use a convolution layer for the first linear projection layer. It's basically just a linear weight because they have strides of S by S and kernel size of S by S, but they don't use any activations, and I think that's taking it a bit too far. How did I structure my project? So I trained from scratch on CFAR 10, 100, then Tiny ImageNet, Flowers, and Pets. And then I load pre-trained weights for ImageNet 1K, 21K for B16 and L16 models, and then fine-tune on all the downstream tasks. I also use a bunch of optimization strategies and learning rate schedules. Let's discuss some results. So without the pre-trained models, we get a massive overfit, which was discussed in the paper as being very common without pre-training. But with pre-training, I get accuracies that are similar to the original paper. Although the original paper only gives us an average of the 5 downstream tasks and not individual scores, but I have the downstream scores for each of the tasks, and I think I did perform well on at least some of them. The flowers dataset was not able to perform really well because I think on the ImageNet 21K pre-trained model, there's only 3 flowers classes, but in the flowers dataset, there are much more. So the performance suffered. And what I concluded was that the pre-training efficacy for MLP mixers is very high, and it benefits from a larger dataset. For example, GFT 300M, I actually have. And then optimization strategies and hyperparameter tuning actually affects the MLP mixer too much. And there were some smaller insights about each of the datasets individually, which I go into detail in the paper that I wrote. Some directions are putting back convolutions here, or putting back attention, or trying some complicated things, or just coming back to MLPs and through some simple things. That's about it. I'm Akash Rastogi. Here are some references. This is about the architecture and how I piped the whole thing up. And here are some more details about the OP's findings. Thank you.